Hello students, in this session we will try to learn the hash functions and properties of hash function. So from today's session we are starting the second part of the unit. Second part is about the security of the blockchain. In that we have to study different topics like hash function, hash pointer, properties of hash functions, then Merkle tree, public key cryptography, digital signature, and zero knowledge system. So we will start with the hash function. Already in previous sessions we have studied the uh, hash function. What is the significance of this hash values in the security of the blockchain network. So unit 1 syllabus is divided into two parts. First part contains blockchain overview and second part contains security aspects of the blockchain. So in previous session we have taken the overview of security aspects of the blockchain. In this session we will study hash function, properties of hash function. So dear students, before starting discussion on hash functions, we know the importance of hash functions in the blockchain. In blockchain, whenever a new block is created, that block contains hash of the previous block. The blocks are linked through the hash values, and the blocks are secured. Blocks become tamper proof because of the hash value, or you can say Merkle root, because if any attacker tries to change the transactions in the block, uh, then that will change the hash value of the block also, and block will become invalid. So we know that blockchain is a chain of hash linked blocks, and each block has a hash value. And if we see the hash value is the fingerprint which is unique to each block. It is the fingerprint of the input data, and it identifies a block and all of its content in the blockchain. It is always unique, just like a fingerprint of any person. So once a block is created, any change inside the block will cause change to the hash value, and the miners or nodes will come to know that the contents of block has been changed, and they will invalidate the block will become invalid, or will come to know that someone has tried to tamper to alter the contents of block. So this is the significance of this hash value in the blockchain. So in previous sessions also we have studied hash. Hash function is a type of mathematical function which turns input data into a fingerprint of that data, and fingerprint of that data is called a hash. It will take the input of arbitrary size, any size. It will take the input of any size, and it will convert that input into the fixed length output that we have studied. That depends on the type of hash function used, how many bits are used for representing the hash. That depends on the type of the hash function. SHA 256 will produce the 256 256 bit hash value. So that depends on the hash function used how many bits it will use for representing the output. So hash function is like a formula which takes input and turns it into a output of fixed length, which represents fingerprint of the data. And there are many types of hash functions. There are different categories of hash function: SHA1, SHA2, SHA3. Other categories are also that we will discuss in the coming slides. And if we take the example of this hash function, if we take a sentence hello from bits on the blocks, and if we apply hash function on this input, it will convert this input into a output, fingerprint output, and that output will look like this. This is the output of SHA256 algorithm, and this output is difficult to understand, difficult to tamper, and it is difficult to calculate the input value from this output value. This is the property of the hash function. It will not allow the reverse function. We can convert input into the hash value, but we cannot convert we cannot reconstruct the input from the hash value. So hash functions are used to create fixed length digest, or you can say fixed length output of arbitrary long input string. It will take the input strings of any size, and it will convert that string into a fixed length digest or fixed length output. Hash functions are keyless. They don't require any key like public key cryptography, in which private and public keys are used. And they provide the data integrity service. There are various families of hash functions such as MD, SHA1, SHA2, SHA3, RIPE MD, Whirlpool, and these hash functions have three security properties, namely pre-image resistance, second pre-image resistance, and collision resistance. So we will see these properties in the next slides. So there are 5 properties of hash functions. First property is compression of arbitrary. Arbitrary means of any size. Compression of any size message into a fixed length digest. Then second property is easy to compute. Then third is pre-image resistance, and then next is second pre-image resistance, and last property is collision resistance. So we will discuss these properties one by one in short. So first property of the hash functions is compression of the arbitrary message into the fixed length digest. This property relates to the fact that hash function must be able to take input of any size. It will take the input text of any length, and it will produce output of a fixed length compressed message. That means if the hash function is SHA256, then this SHA256 will take input of any size, but it will produce an output of 256 bits, and this 256 bits is fixed. It will produce output of 256 bits for any type of input. So hash functions produce compressed output in various bit sizes. There are different lengths of output that depends on the type of function. It may produce 128 bits output, it may produce 512 bits, it may produce 160 bits, it may produce 256 bits output. That depends on the type of algorithm we are using for converting the hash value into the input into the hash value. Then second property of the hash function is easy to compute. Hash functions are efficient and fast one-way function. One-way functions means if we give the input, it will produce a output of fixed length. And if we try the reverse function, if we try to construct the original input from the hash value. It will not allow, it is not possible to construct the input value from the output hash value. This is the one way function. It is required that hash function be very quick to compute regardless of the message size. So the second property of the hash function is that the hash function should be such that they should be quick to compute the output, and the efficiency of this algorithm may decrease if the size of the message will increase. If the message is too long, then the efficiency may decrease, but the function should still be fast enough for any practical use. So this is the it should be easy to calculate the hash values, and it should calculate the value within the reasonable time. This is the property of the second property of hash function. Then third property of hash function is pre-image resistance. This property can be explained by using the simple equation. You can see the equation in the figure. There is a equation or function h. H is the hash function, and if we give the input value x to this hash function, this hash function will produce the output value y. H is the hash function, x is the input, and y is the hash output from this function. So this third property says that y cannot be reverse computed. That means computed to x. That means we cannot calculate the x from y. We can convert the input value into the hash value. This is the one way function. We cannot use in a reverse manner. That means we should not be this hash function should not allow to calculate the input value from the hash value. This is the one of the property of hash function. So this hash function is considered a pre-image of y, hence the name pre-image resistance. X is considered as a pre-image of y. That means we cannot calculate the x from the y. This is also called a one-way property. The hash functions are one-way functions. They can convert the input into the hash value, but we cannot calculate the input from the hash value. Then next property of hash function is second pre-image resistance. So we will try to understand this second pre-image resistance property. In this second pre-image, the second pre-image resistance property requires that given x and hash function h, it is almost impossible to find any other message m where m not equal to s and hash of m equal to hash of x, or hash of m equal to hash of x. This property is also known as weak collision resistance. So this second property guarantees that we cannot have a message, another message, second message that will point to the same input. That means if we give the inputs x, we cannot have another output that can be produced from taking another input. So this is the second pre-image resistance property of the there cannot be duplicate hash values, but in some cases there may be duplicate hash values, but it should be practically it should be difficult practically to calculate such kind of duplicate values. So this is the third property of the hash function. Then collision resistance. The collision resistance property requires that two different messages should not hash to the same output. There should not be two inputs that will point to the same output. In other words, hash of x should not be equal to hash of z. This property is also known as strong collision resistance. So due to their very nature, hash functions will always have some collisions. There may be some collisions, there may be some inputs that will point to the same output, but it should be computationally impractical to find that the two inputs are pointing to the same output. It should be difficult. It should be computationally difficult to find that the two inputs are pointing to the same output. So a concept known as uh, avalanche effect is desirable in all functions. This effect specifies that if we try to change the single character in the input, it will entirely change the hash output. That means if we try to tamper the input, if we try to alter the input, it should change the hash value drastically. So this is the important property, avalanche effect. So because of that, in blockchain technology, if attacker tries to change the contents of block, then it will change the hash value of the block, and block will become invalid. So there are different hash algorithms. SHA-0, this SHA-0 algorithms will produce 160 bit output. These algorithms are introduced by NIST in 1999. Then SHA-1, which was introduced in 1995 by NIST as a replacement of the SHA-0, and this algorithm also produces a 160 bit hash output. And then SHA-2, this category includes 4 functions defined by the number of bits of the hash. So depending on the number of bits the output produced by the hash functions, and there are different algorithms like SHA-224, SHA-256, 384, and SHA-512. SHA-224 will produce 224 bit output, 256 will produce 256 bit output, 384 will produce 384 bit output, and SHA-512 bit algorithm will produce the 512 bit message digest. SHA-2, this is the latest family of SHA functions. SHA-3 includes SHA-224, SHA-3 256, SHA-3 384, SHA-3 512. These are members of this family. Then SHA-3 is introduced. SHA-3 is just NIST, a standard version of KECOC. This algorithm is based on the Merkle-Damgard transformation. So we will see what is this Merkle-Damgard transformation. Then RIPEMD is the short form for race integrity primitives evaluation message digest. So message digest, it is based on the design ideas used to build MD4. Then Whirlpool, this is based on a modified version of Reasonadale cipher known as W. It uses the Miyaguchi prenyl compression function. So dear students, you just remember the names of these different types of hash functions. We will not go into the details, and it is not necessary to go into the details of these hash functions. We should know what is hash function, properties of hash function, and names of different types of hash functions: SHA-0, SHA-1, SHA-2, SHA-3, RIPEMD, and Whirlpool. Then you can see one of the example how the hash function works. So this is the algorithm. This construction is used by SHA-3 algorithms, Merkle-Damgard construction algorithms, construction for hash function. So you can see from this we will come to know how the hash value will be calculated. We will not go into the much details. And if there are different types of hash functions use different mechanisms. So it is beyond the scope of this unit 1, and if we try to explain all these algorithms, the students, you may get overloaded by this information. So we have to just take the introduction of this hash functions, and in that way I am not going into much details of these various algorithms. So you can see this example in this technique. Whatever the input message we give to this hash algorithm, this message is divided into fixed size blocks. If the size of the block is 512 bits, then it will divide the message into the blocks of 512 bits. If the block size is 64 bits, then it will divide the message into the blocks of 64 bits. It uses a then after dividing the message into the if the size of the block is less than the predefined block size. Suppose we have defined the block size 512 bits, and if the size of the message is less, then padding is used. Padding means to make it 512 bits, zeros are appended at the end of the message, so that block size will become 512 bits. Then it uses a compression function f. You can see in the figure. Uh, uh, in the figure, you can see it has the function f. This function f, you can see this function f will take a chaining variable as an input, and this message block, this both values, it will take the input, message block and chaining variable. Then it will produce the output. Then in the next stage, it will take the second block of message and chaining value from the previous function, and from that it will produce the another output. So this process will be continued. Uh, uh, this process is continued. If we have 10 blocks, then this process will continue for 10 blocks, and final chaining variable is the hash value, is the output hash value from this Merkle DAMGuard construction. So you try to understand basic concept. It is not necessary to go into the details of this. There are several algorithms, and if we go into the details, we may require 5 more sessions to explain all this concept. So this is the beyond, not possible. This is the beyond the scope of this subject. So you just try to understand the basic concept. So students, in this session we have taken the introduction of hash functions, properties of hash functions, and different types of hash algorithms. This is about today's session. We will stop here. Thank you and goodbye.